What I wanted to talk about tonight was something that you've all seen and you might have been wondering about. And I've got lots of a lot of my work is hands-on, show and tell. I really find it important. Different people learn things different ways. And one of the things that drives home points to me is being able to actually see what someone's talking about and compare it with what's going on. And in that regard, I brought some examples of wire and why we want to talk about it tonight. And like you see up there, can everyone read that? Is that readable from the back? Great. Real copper wire is expensive and it's heavy. And you go to a ham fest and you think, there's this nice ham fest vendor, they're selling copper wire. My gosh, I look at it, it sure is copper. And man, is it cheap. And man, is it light. And man, is it ever flexible. That's the stuff for me, because if you go buy that Belden wire, Alpha wire, boy, that stuff's really expensive. I mean, you're talking 3 figures for 100 feet. So I'm going to pass around some examples you can look at while I talk. And here's the first round. Here's your typical Hamfest wire. I bought this at a Hamfest because I wanted 8 AWG wire, 8 American wire gauge wire, American wire gauge. If you look at this closely, you'll see 2 examples. This white wire is sized according to AWG. This stuff here, it just says gauge. They don't even bother giving you a number. And I don't know what gauge means. Does anyone know what gauge means? What's that?
It is the number of lead balls that will go down inside the barrel that equal a pound.
That equal a pound, right. 12 pounds. And that's the far more relevant definition, Jerry, than anything you'll read on this kind of wire ever. So here we have real 8 AWG wire from a top vendor. You can't see that, but right there, it's $489 for 100 feet. That's this white stuff, and I'll start passing it around. And that's, up until recent years, all you could buy or all you would buy. If you want 8 AWG wire, that's what you get. If your current and voltage drop budget calls for 8 gauge wire, that's what you get. Below that is a web page from a very popular Hamfest vendor. I'm sure you've all seen her at Hamfest. Wonderful woman, wonderful company. She's selling the stuff that is available. And if you go on eBay or any web page, you buy audio products, power distribution for these guys with the thumping audio systems in their cars, what you're going to buy looks just like copper wire, but, and it solders like copper wire, smells like copper wire, crimps like copper wire. It ain't copper wire. That Alpha wire, $489 for a 100-foot spool, and if you were able to buy 100 feet from one of the Hamfest vendors, it's $150 or less. That's actually a high price. The Alpha wire is copper. What she doesn't tell you, but the Hamfest wire is copper-clad aluminum wire. It is aluminum wire, flash-coated with the thinnest possible copper coloring they can put on it. That's why it's so light. That's why it's so flexible. That's why it's so cheap. Now, CCA wire has been around for a long, long time. It's what's used in this wire right here, because you're not pumping amps through this, and you're not. It doesn't really matter. It has applications. The voice coil in your speakers, almost invariably CCA, if not just pure aluminum itself. There's a need for lightweight wire. But even among CCW, copper-clad aluminum or copper-clad aluminum wire, whatever you want to call it, there's variations in that quality. Some of them have 15% copper cladding. Some are 1/3 of that, 5%. And I'll bet you can go even lower than that and it still looks like copper. It solders well, it crimps well. That copper on there is real copper, just not much of it. And I'm in the world of reliability nowadays, and I'll just pass on a tip. If you crimp a wire, don't go ahead and solder it too. I know it sounds like a great idea, but someday we could talk about all the reasons why it may not be such a good idea. AWG, that's a real definition created by real engineers for real reasons, going back a long way. And AWG is a cross-sectional area. They measure it in circular mills and all these other things. And AWG, if your wire is measured in AWG, it'll say AWG on it. If not, be suspicious. If it's not printed on the wire, they're not proud of their wire. Here's another pass around. But when you are buying wire, especially for a power application, the words UL or CSA, Canadian standards, are very important. I've been at UL doing testing. I've done flame testing for electronics, flame testing of insulation, burn rates, current carrying capacity of different electrical products. And when you see a UL rating on something, you can really take it to the bank because they literally do take it to the bank. They underwrite the insurance company. You can't get a policy unless your policy is certified by the underwriters' laboratories, and that's how that works. By the way, one of the things we do, or I did at UL, the burn test. You would have a Bunsen burner. Remember those? Bunsen burner? And on a table, your test sample will be clamped above it to get into the flame, and laying on the table would be cotton batting, just like you could pull out of a mattress. And you would ignite the product sample, whether it be wire or a piece of plastic switch from a piece of electronics, the housing that your laptop is in, that type of plastic and so forth. It's allowed to get hot. It's allowed to melt. It cannot catch the cotton batting on fire. It has to self-extinguish as it drips. And when you see electronics with little holes in it, ventilation holes, those holes are designed such that when melted plastic passes through the holes, it extinguishes. It can come out, it can stink, it can smell up the room, there can be smoke. It just can't catch things on fire. So the wire that I'm passing around, the two types, one has a UL rating, one does not. And I don't know if their insulation is bad. It may not be bad, but it doesn't carry any kind of test approval with it. So the question is, do you want to put it in your car or in your home? But that's why this stuff is so cheap, you can't possibly go to a ham fest and sell that white wire you see passing around. It'd be way too expensive. Everyone would say, oh, I just want some 8-gauge wire. This guy wants $489 for a 100-foot spool. This guy wants $150. What's the ham fest folks going to do? You'll never make a dollar. I'm going to talk just briefly about voltage drop, if I can get my screen lined up here. You have a certain amount of voltage to present to a mobile radio. Typically, that's going to be 13.8 volts. That's what comes out, typically. That can vary. My radio that I got from Farrell a long time ago, Kenwood TMD 700, draws peak power, its peak current draw on UHF, which is your highest current consumer, is 11.5 amps. So I need to be able to deliver 11.5 amps from the battery terminals through the engine compartment, through the firewall, through fuses, a disconnect switch, a distribution box, that silly little T connector they put in the back of ham radios, and right up into the finals and the transistors. So when you say voltage drop is I times R, you can't just say, well, it's so many ohms per foot or milliohms per foot of the wire. You got to take into account all the connections. Later on, we can talk about this nifty meter I have here. You can look up on any wire gauge table and find the resistance of your wire, and you can trust it or you can not trust it. Or you can measure it, which is what I do. This is a milliohm meter made by Hewlett-Packard, designed in '65 for the Cold War. This was designed to measure resistances through dissimilar metals. It was designed to measure the squibs that ignite the igniters, that ignite the TNT charges in the ring around the plutonium ball inside ICBMs. And you have to say to yourself, you're a nuclear missile technician, and your boss says, why don't you hook up an ohm meter to them igniters? And you say, why don't you go fly a kite? So HP and Yokogawa Instruments in Japan, we were closely aligned with the Japanese at this point against the evil empire. And they designed a meter that puts out picoamps of current. Picoamps. So they won't activate the igniters, the ICBM will stay in the silo, and everyone will be happy. And it's not just picoamps of current. Because when you're all familiar with how a DC ohm meter works. It's a current source, which is a battery, and you measure that voltage flowing through a load, and the currents developed is read by the meter, and you say that's ohms. Well, what if your wire is copper wire screwed down to a stainless steel screw that goes into a beryllium connector that has nickel-plated contacts, and it's humid, and you're in the plains of North Dakota in a missile silo in the winter, and there's salt and corrosion and everything else. All those metal-to-metal contacts, you've all put copper and zinc into a lemon, and it forms a battery. And all those dissimilar metals in the presence of an acid, like hydroxyl acid, which is what we call water, forms a battery. And now you're going to say, oh, I'm going to measure all these batteries with what? An ohm meter and a battery. What are you going to measure? Not reality. The geniuses at Yokogawa Instruments and HP said, you don't need to use a DC current source. Use an AC current source. 1 kilohertz sine wave. Send it out to the load, send it back through a capacitor. None of the galvanic effects of what you're measuring comes back in. You just measure the phase and amplitude change of the signal going out, signal coming in, displayed on a meter, there's your resistance. It's a beautiful system. These are going for about $2,000 on eBay. They haven't been made since '78. There's nothing like it in the world. No one else makes them. Once HP stopped, that was it. But this is what I use to measure wire, especially measuring wire in cars, because guess what? It has a capacitive coupling, so I could have the engine on, the battery on, voltage is flying everywhere, and I'm measuring resistance between the alternator, ground, and the battery, and I got DC all over the place, and I'm using an ohm meter, and you're looking at me saying, what is your problem, man? You're going to blow that thing up. But you don't. We can talk about that another day. We can actually measure your wire. If you ever have wire you want to measure, this is what we'll do it with. I'm going to say you got 20 feet of wire, 10 feet of positive, 10 feet of negative wire. You got fuses, you got crimps. We're going to say you got 1/10 of an ohm for all those crimps and fuses and contacts and blah, blah, blah. Your battery voltage. These are some typicals. You could measure them to get your exact. But you really want 13.8. You may get 14.4. That's nice. You may be down to 12.2 or lower. And a lot of ham radios I've found the hard way that it's sitting there running, the display is lit up, you got 12.2 volts. As soon as you key the mic, it says, you don't got enough voltage, I'm going to draw too much current, I'm going to shut you down. And they do. That's the case for minimizing voltage drop from your battery to your radio. That's one case. You want your radio to work. This is what I measured. By the way, this thing will measure 1/1000th of an ohm full scale. So you can look things up in a wire table or you can measure it. And that's what I measured. The cheap no-name wire has over twice the resistance of real copper. And you see these numbers have a lot of zeros in front of them. You think, well, they're pretty small numbers, but look, one is twice as big as the other. That's a lot of difference. And that difference gets converted into heat. So if you multiply that resistance times the current, and you get voltage rather, and you get watts, and you're dissipating how many watts in that piece of wire. Meanwhile, you want those watts to go out to the world, not heating up your dashboard. There's the actual voltage drop, the difference. The cheap wire has over 1/4 volt of drop. The good wire has far less. So remember, think back at your battery voltage. Is your battery fully charged? Is it running well? Do you have 13.8 or do you have 12.2? You got that window of battery voltage that your radio is going to work with. So you want to minimize the voltage drop to the radio from your battery. Because you might be sitting there, you might be out of gas. You might be calling someone to help you come get you. The engine isn't charging the battery. The battery's running low. You want as much voltage coming to the radio as possible. There's another reason for that. Temperature. That wire gets hot, and in the engine compartment, it's already pretty doggone hot. How much hotter do you want your wire to get? How much temperature rise do you want? The wire we're passing around, if you read the label, you'll see it's rated for 105 degrees C, or 220 degrees Fahrenheit, above the point of boiling water. The passenger compartment, just ask your dog, 90 degrees C or 195 degree F. The real 8 American wire gauge wire has a UL and CSA stamp, and it's rated to 105 degrees C, and you can test that. Take a lighter to it, see what happens. When you buy wire, take a lighter to it and see if it drips off with flames or not. Make yourself feel better about what you're buying. You can't do that at a ham fest, though. You'll attract too much attention. The insulation breakdown on that wire, it says 600 volts, and by God, it is 600 volts or more. That's minimum. It's probably much more than that. It's probably, what they probably say there is probably 2/3 of reality. It's probably more like 900 volts. You don't know what the insulation breakdown is of that other stuff. You got no idea. What's their quality control? Do they have pinholes in it? Is water going to get in it? You don't know any of that. There's a reason that when you look at these radios, a vast part of the radio is a heat sink, or you got fans. And that's because the transistors are pumping out current, lots of current. And heat is related to current. In fact, it's squared. So watch the current. As your battery voltage goes down, current goes up pretty quick. And it's current that makes heat, and that heat is going to make your radio hot, and your radio ain't going to like that, and it will shut down. It has thermistors in it. It will shut itself down to protect itself, but do you want your radio to go through that strain? Because when you make the transistors real hot, they start to move away from the printed circuit board, and connections start to bend and flex. And over time, that bending and flexing, heating and cooling, heating and cooling, heating and cooling, and all of a sudden one day you go to turn on your radio, it doesn't work, and you're wondering why. Something broke. Heat does things. Here's some more things I'm going to pass around. I was on eBay looking around for fuse holders. I wanted 8-gauge fuse holders. They were cheap. I got like a dozen of them for $12. Got them at home. First thing I did was take a pair of dikes, cut it open, look at the wire, measure it. And it's not 8-gauge wire. And the vendor on eBay was thoughtful enough to put his phone number on the auction. So I called him. And I said, you know, it's not 8. Yeah, I know. Well, why do you sell it? Well, it's the only thing you can get. Yeah, but you're lying about it. Yeah, everyone does. And he's right. They do. He does. He changed his auction to say, at least what he did was, oh, by the way, he refunded all my money. I still have these things. If anyone wants one, take some home. Pass them around. They're good. They're just not 8-gauge. If you need to fuse 12-gauge, that's your fuse holder. They're waterproof. They're not bad. But on his auction page, he changed it from 8 AWG to 8-gauge. And again, what is gauge? We don't know. He don't know. Someone in China knows, and he just puts whatever he wants on it and sells it, and that's that. So our takeaway, safety. You can go online and look at pictures of ham radio installations where the whole dashboard is melted plastic because of a short. I'm not saying that you guys all know better, but it can happen, and it can happen to you for a lot of reasons than just pulling too much current. It could be crappy insulation. It could be insulation that doesn't withstand abrasion. So what I'm passing around there, you're seeing cover all your wires with loom. The loom is cheap. If you go to an installer and you say, put some loom on, he's not going to have it. You're going to have to buy it yourself. Buy some, when you get a mobile radio installed, buy some loom and say, please use this stuff. Cover every inch of wire with it, because inside a car, things move. And things are sharp. You ever put your hands underneath your seat to find your keys? And you think, why did they put scalpels underneath the seat? And your hand comes out like a stump. And so everything is sharp everywhere, and your insulation has to be protected, and put some loom on it helps. You can use CCA wire. I'm not condemning it. I question it. If you could find an application where you could tolerate the lack of safety information, the lack of current carrying ability, the voltage drop, insulation quality, use it. I do. I have. Jack? Oh, I passed it around. It should make it to you soon, Jack. It's just a mesh jacket. A jacket is a better word. That stuff. And anything will do. Anything's better than nothing at all. But if you use CCA, remember that voltage drop chart. It drops a lot more voltage than you think it should. You can get around that. If you need 8-gauge, buy 6-gauge or buy 4-gauge. It's going to be thicker and heavier, and then you start saying, well, is it really cheaper after all? Can I really count on it? Should I just call up Belden or Alpha and send me some real, honest-to-God, American copper wire? It might be worth it to you. A few little tips. We're getting toward the end here. These battery disconnect switches are something that have always been around, but they're a lot cheaper now because you get the guys with the boom and thumping audio systems. They're actually providing a great service to ham radio because there's all kind of components now that are cheaper and more available than they've ever been. Walk into the audio section at Walmart sometime. You'll be amazed at the high-powered DC distribution products you can buy for not a lot of money. And in spite of the wire being of poor quality, all the wire you buy there is CCA, all of it, invariably. But in spite of that, some of the other products are pretty good, especially like those disconnect switches. They're not bad. The fuse holders are great. And lastly, when you install the radio, when you're running your high power, one of the other protective things is right there at the firewall, make sure they put a nice grommet around it. A lot of flux in there, a lot of heat there. I'll tell you what, I know a guy, when he was 19 years old, thought he knew every damn thing. Put a lot of audio stuff in his car. It was 1978 it was. I remember it well. And back then you couldn't just buy wire. You couldn't buy heavy-duty audio stuff, and I just improvised with whatever I had. And I had a short right there. I had a short right in the firewall in a Chevy Citation. And it started to melt and stink as I was going on the Pennsylvania Turnpike. And on the Pennsylvania Turnpike, if you've ever been on it, you can't just pull off. It's a toll road. Yeah, you can pull off, they're going to charge you for that. Even though you're driving, coming through the toll booth, smoking and stinking, you're like, planes, trains, and automobiles, you're flaming. Pay the toll. So that's what I have. Any questions, guys and gals? Yes?
Why don't you crimp the solder?
Crimp lugs and stranded wire when you solder them, the solder gets to a crystallized state and is very brittle. And it wicks up the wire to some undetermined length. And it makes the wire very prone to breakage. And although you may think you're getting a better connection, and you are getting a better DC connection with the solder there's no question about it. For connection quality, it can't be beat. Solder is it. But a proper crimp should be gas tight. And what they mean by gas tight is when the crimp squeezes around the wire, gases should not be able to penetrate that contact surface. It should not oxidize. It should be a very good connection for a very good time. But when you have solder wicking up inside the insulation, the wire and that terminal, in terms of failures in time, fit numbers and so forth, reliability and mean time between failures, that was rated without solder. Solder changes all the attributes about it. And speaking of crimping, when it comes to crimping, yes, Jack? That's great stuff. It's great stuff, Jack. Yeah, it does, and it prevents moisture for a long time. It prevents dendrite growth, growth of little fingers, whiskers, and those whiskers cause mechanical force. The mechanical force causes separation. When you have separation, you have arcing. When you have arcing, you have heat. And all of a sudden, you're wondering one day, how come my computer power supply doesn't work? And in the early 2000s, there was lots of computer power supplies out there that were working one day and not the next because they figured out they get these nut jobs that say you can't have lead in electronics. God commanded that there's lead in electronics. He'll tell you. Just ask. They take the lead out, and along with it goes reliability. All consumer products, you'll see ROHS, RoHS, reduction of hazardous substances. And among those substances are lead and beryllium, two of the things that make military electronics solid. By the way, RoHS doesn't exist in the military. The military products that we produce, if there's not lead in it, they test for the lead. And they say, if there's not lead in it, we don't buy it. Meanwhile, when we sell stuff to the commercial world, they test for lead. If there's lead in it, you go to jail, you get fined. That's the difference. And you say to yourself, do I want military reliability, or do I want to satisfy some crazed environmentalist that doesn't understand that human life depends on electronics nowadays? It's a hydraulic jack. I love this thing. For crimping big connectors, you wonder, all right, Thomas, I got these big connectors. How do I crimp them? Well, you call me up and I'll let you borrow this. That's a hydraulic jack. And it comes with a bunch of different dies for any kind of big lug you got to crimp onto your battery. This is your boy right here. My son uses it to crush bugs. Another question. Oh, Mark got his for $19 on Harbor Freight.
19?
Yeah,
Yeah, Harbor Freight will have those on sale. I think they normally run like $49.
that's what I paid for mine.
Now and again, 2 or 3 times a year when they're throwing stuff out, you might find a coupon at
When I make these measurements of wire and so forth and distribution systems, even with my glorious meter that I brag so much about, which I love, I also have this. This is a 10 ohm resistor. And you're thinking, 10 ohm resistor? It looks like a dummy load. It'll only handle a watt or two, but it's for calibrating instruments. This is 10.0000000 out to 6 zeros ohms over temperature. And so if you're ever wondering, does my fluke ohm meter really read properly? Call me up. You borrow this, calibrate your stuff with it. By the way, briefly, I was talking to some engineers about this today where I work. We had to measure a bonding resistance. You had to have a very low impedance to ground. 25 milliohms. 25 1,000ths of an ohm. And he's out there with a $200 fluke meter saying, measure 0. I said, great. It ain't 0. Yes, it is. It's a fluke meter. See? 0. You got to get one of these. Here's why. And here's how I explained it to him. I said, you're standing in your garage. I'm driving your car, Brian. I'm driving your car. And you're up against the wall in the back of your garage. You're standing there. I'm driving right towards you. Speedometer says 0 miles an hour. But you see I'm moving towards you. Do you think it's going to hurt? But your meter said 0. There's a lot of room between 0 and 1. An infinite amount of space. This measures quite a lot of it. Any other questions?
What about for DC? I can understand the issue with the top-clad aluminum.
Yes.
What about where you're using it, say, for ground wire or something where a lot of what you want to do is dissipate induction spikes and lightning or something?
Excellent question, Jim. Because in lightning, by the way, and Jim, I know he knows a thing or two about cable TV. And so I brought some cable TV distribution coax. This is Heliax, Andrew Heliax, real expensive stuff, the real good stuff. Guess what the core is made out of? Copper-clad aluminum. They have a whole other reason, skin effect. Because the majority of the current, the DC current and the AC current flows on the outside of that. Most of the current flows through the field between the outer shield and the center core. But a good deal of the current also flows along the wire itself. I'll pass it around. But you can see, I sliced it up so you can see that inside this expensive, best kind of coax you could buy is CCA inside there. In terms of ground wires for lightning, my favorite topic, been hit twice. And so then I became a person who does lightning testing for military stuff, and I know Rob's been part of that. And when I first got into it, I didn't know a whole lot. And the first time my house got struck by lightning, because I didn't fully, I was gambling. I live right at the base of Sawney Mountain. I said, well, if lightning's going to strike, there's this 2,000-foot mountain. It's going to strike there, right? No. It hit my house. It hit the pine tree. The whole house smelled like pine sol. It really did. The yard, there's bits of pine tree all through the yard. In a nutshell, lightning. If you have multiple places that are ground sources, ground rods for your service entrance by your electric meter, ground rod up by your dipole antenna, ground rod for your radio, what you just gave lightning was 3 places to go, and it's going to go to each one of them, divide its voltage amongst them proportionally. And as my friend Greg Abernathy, AU4D, told me, lucky you didn't burn your damn house down. That was a quote. Because I was gambling that the lightning was going to strike on Sawney Mountain, not in my house, and I had too much inductance in the ground system that was existing. I was a new ham, and I thought, I'll just throw this together, and what's the chances of lightning coming? And, well, it came twice. And in terms of the wire you use for that, and Jim's question is, should I accept the high DC resistance of CCA or aluminum wire for my ground rod? And the answer is, we don't care about DC resistance for lightning so much, because lightning's an AC pulse. It's a high frequency pulse. Figure it to be 300 megahertz or so. And you ask yourself, if I was 300 megahertz, would I go through Tom's big long piece of pure copper wire? Or would I prefer to go through a short little Jim's aluminum wire? And the answer is, you go through the short wire first. Less inductance. And inductance is the key. So if your choice is a high quality copper or short aluminum, always take the short wire to ground as soon as possible. Have one ground point for everything. One. Have all the lightning come to that one ground point. Have your radio grounded there, your service instruments grounded there, your coax grounded there, all of it right there on that ground rod. And I have a meter, another meter at home, that measures the impedance to earth. We do call it fall of potential. We inject a voltage in the earth and we see how much voltage drop we get over some span of 10, 20 feet. And that'll tell you precisely how many amps of lightning you can dissipate into your ground system. So when it comes to grounding, use whatever wire you got, but make sure it's short. We can improve on it, but until you improve on it, make it short and make it one ground point. Don't do like I did and say, oh, I got a nice ground rod right outside the shack, went into an 8-foot ground rod, and then 30 feet over there was the surface entrance ground. Lightning went to both. In between was my $3,000 ham radio. Went right through it. It was under warranty. By ICOM. They fixed it. Any other questions? John?
That situation where you have a ground, say, where your antennas is in your home. Around on the other side of the house, there's
The service entrance.
power company put in a telephone.
Right.
Whatever. Everything's hooked to that except you.
Except you. And so what you have to do is change that. And the best way to change that is, in my case, and hey, I got this this board here I'll use. Do we have any markers handy?
Yeah, just beside the meter.
Just beside me. Thank you. This is a great question. And what John is saying is, at your house, in your yard, telephone pole, wires, you got maybe a transformer, underground utilities or whatever. In any case, you have the service entrance, your two HOTS, your 230 volts, reference to a ground wire. And that ground wire dutifully goes to a copper ground rod. By the way, that's copper-clad steel, right? It works. And then this goes into your breaker panel. All your breakers, right? And then off that breaker panel, you got 110 volts going to your Radio Shack. And then out of the Radio Shack, you got your pine tree back here. You got your dipole strung up between them. And you say, well, before that shield comes into the house, I'm going to pound it into a ground rod. And the lightning comes. Let's say it comes here. Doesn't matter. Lightning comes here. Half of it goes here, half of it goes there. A lot of it travels right through there. You just gave it a path. Same thing if lightning strikes here. You gave it a path right through your house. Take out everything in between. I had a Ethernet router. How much current can you carry through a piece of Ethernet cable? I found out. Yeah. And by the way, that's CCA also. That's why it's so light and flexible. Enough current to, I have these equipment racks, right? These, cabinets for electronic junk. On top was a little Cisco router in a little metal box. And after my lightning strike, I thought, well, none of my Ethernet stuff works. I'm going to replace this. It was welded to the top of the cabinet. And all of the current to do that spot weld came through Ethernet cable, because that's the only thing that was connected to it. So when it comes to lighting, grounding, and bonding, what do you do here? You do want this ground here. You do. Heck, you may want one out here. It's even better. Ground the shield of your coax there, shield your coax there. You should do that. Here's how to make it safe. You get another color marker. Let's use green for ground. You connect them together. And you do that below grade, 24 inches below grade. Make sure that wire can always be wet. Make sure that wire is bare. And you do CAD welding, CAD welding. That's the exothermic welding. And you weld those ground wires to ground rods. And since your ground rods are 8 feet long, every 16 feet, sink another one if you're going real far. And so when the lightning comes, it's going to go through this path rather than through this path. And again, with the meters, when you hook this up, we could actually measure and make sure that lightning's going to take that path. Nevertheless, when lightning comes, unplug your stuff. Yes, sir. You can make a perimeter ground around the house. Bond your downspouts to it. It's called a halo ground. Your downspouts, bring everything to those ground rods. Don't have them too close. You're thinking, well, if one ground rod is good, Tom, 2 are better. Only to a point. When the lightning comes in here and it sets up an electromagnetic field around that, right? And let's say you had another ground rod right there. And you got an electromagnetic field from one conductor to another. In ham radio, we call that a transformer. And you've just induced new current into here. So now you got a big problem on your hands. You got current being generated and redistributed with your ground rods. That's why your ground rods should be far apart. And a rule of thumb, and it's just a rule of thumb, the ground rods should be twice as far as they are deep, apart. When you look at your ground rod, run out there tomorrow when the sun's shining and look at it. Your ground rod is copper-clad steel, and there's an acorn nut on it. And you got your number 10 piece of wire going up to your house into your panel. Make sure, and when I said unplug everything anyway, that's because we haven't covered all of our bases yet. We haven't looked at the phone wires coming in. We haven't looked at cable TV wires coming in yet. We haven't looked at your sprinkler system. We haven't looked at any of that other stuff, all those other conductors and things that deliver lightning currents to your home. So until you do, take that antenna take that coax off your radio, throw it out in the yard. By the way, I had my coax off the radio, sitting on a wooden bench, just like that. I had a brand new MFJ antenna analyzer, the best one they make. That's $400, something, sitting this far away. The lightning came, jumped out of that coax, went right to the meter, fried it, on the wooden desk. It wasn't plugged in anything, it was just sitting there, minding its own. So anyway, you got this ground rod. It should have the number 10 wire going up to your breaker panel. It should have the wire going to your cable TV box. It should have wire going up to your phone box. It should have a wire going up to your irrigation wires if you got those too. And then take a real close look right there. Is it nice, flat? Or does it look like someone beat the heck out of it with a hammer? It's all mushroomed and distorted and cracked. That's what you want. Because that's evidence that someone actually pounded it into the ground. In my neighborhood, I measured some of my neighbors' grounds. Some of them, the National Electrical Code says it should be 25 ohms. Some of them I couldn't measure. They were just open circuit. Because what they did, the installers, they were pounding this in and hit a rock. I'm not pounding it anymore. That's too hard. So they stopped. Took a hacksaw, cut it off nice and clean. You didn't know. Looks like you got a ground rod. The top is real clean like that. It should be mushroomed and beat to death because it should be beat down as far as it can go. Any other questions? Yes, sir. There's a fall potential meter has at minimum 3 connections. One goes here to the meter, and at least 2 others go out here to a little spike you stick in the ground. Another one goes further out to a spike you stick in the ground. And in my lightning presentation, we talked about ground potential rise, GPR. When lightning strikes, it's exactly like dropping a pebble into a pond. You throw the pebble out in the pond, and the lightning currents radiate out from where it struck. And that's why, when you have all these ground rods, the lightning pulse may hit this one first, and this one, and this one, and this one. And if they're all at the same potential, you're okay. If they're at different potentials or not connected, you got a problem, like I did. Vince Pardinas did me the great favor of translating an article from a newspaper out of Brazil, where a small town had a lightning storm come through. There's a bunch of cows in the pasture. Lightning struck a tree. Some cows died. Other cows didn't. A cow standing right next to another cow. One died, one didn't. What happened? And they had all their theories. Well, this was a different color cow. This was a better behaved cow. Cow of a different color. A holy cow. I don't know. That's what it was. Some cows were standing like this, all four legs, and those pebbles from the pond radiating out came in one side and right down the other. Very short path. From here to here, very short path. Other cows, unfortunately, were standing here. And now it's about 6 feet between the front legs and the back legs. And that current went right through their cardiovascular system, and they died. I was trying to read the article. Vince translated it. He said, "Oh, it's very simple. Ground potential rise, Tom." I said, "Cool, Vince. Thank you." What else? All right.